Hello friends, my name is Chinmay Deshpande. I am from Department of Electrical Engineering. In this video lecture, we are going to discuss about basic laws of electrical engineering related to motor and a generator and generating and motoring action. Now, first we will discuss what is a Faraday's law. This Faraday's law of induction describes how an electric current produces a magnetic field, and on the other hand, or conversely, how the changing magnetic field generates electric current in a conductor. Now, Faraday used a cardboard tube with an insulated wire wrapped around it to form a coil. So this was the coil he used for this experiment. A voltmeter was connected across the coil and an induced EMF read as a magnet was passed through a coil. So this was the magnet. Now what he observed, what happens whenever this magnet is kept near to this coil? When it moves through that coil, when it moves towards that coil, and when it moves away from that coil. So now we will also discuss this experiment. Now this is what is a setup. Here you will observe that this is a bulb which is connected. This is a coil. This will be north and the south pole. Now let's check first case. Whenever this whatever magnet which is placed, it is at rest position. So what you observe here? No voltage is generated. So whenever the magnet is kept at a rest, no voltage will be generated. Now suppose if I move that magnet towards the coil, now you will observe there will be a deflection and the bulb will glow. And whenever we move that magnet away from that coil, again there will be a deflection. So in order to produce a current, there has to be a relative motion between the conductor or the magnetic field. Now here the conductor is stationary, it is fixed, but the magnetic field is changing. So therefore when I pass it again near to this, there will be deflection. Now what we will do, we will check for a field lines also. These are the field lines. Always remember, the field lines are from north to south pole outside this magnet. So therefore you will observe that there will be deflection whenever that magnet passes through the coil. Now let's change the orientation of that magnet. So in first case it was north and south. Now in second case we will take here south and north. Now what is observed? Again when we keep near to this, there will be deflection. When it passes through that coil, again there will be deflection. So what we observed, we write it as a conclusion. So here we will say that the observation are, whenever the magnet is at rest or near to the coil, no voltage was generated, no reading will be observed. Then when magnet is moved towards the coil, some voltage gets measured, some voltage gets generated, rising to a peak as the magnet nears the center of a coil. Third one will be when magnet passes through the middle of a coil, then measured voltage rapidly changes its sign. Then whenever a magnet passes out and away from the coil, so voltage measured in opposite direction here to the earlier case of the magnet which is moving into the coil. So these are the observations that we observe. So Faraday observed that whenever current flows in the coil, only when there is a relative motion between coil and the magnet. Now what is the meaning of relative motion? Either coil has to be moved or magnet has to be moved. That is, either conductor is to be rotated or there will be changing magnetic field. Now here you will observe that according to Faraday, whenever there is no relative motion between the coil or the magnet, then the magnetic flux within the line remains constant, and therefore here galvanometer will not show anything or there will be zero deflection. So here you will observe that this is a magnet which is placed at stationary. Now whenever it keeps at a stationary position, then no field will be generated, and here you will observe no deflection by a galvanometer. But whenever a magnet is moved towards the coil or vice versa, the magnet flux changes and therefore the EMF, that is electromotive force, gets generated, induced in the coil. If the circuit is complete, if it is short circuited, then current starts to flow through it. So therefore here you will observe that whenever this magnet is moved towards a coil, Then as it is a short circuited, so therefore this yellow color indicates that current flows through this. So remember that what Faraday says, there has to be a relative motion between coil or the magnet. Whenever coil is fixed and the magnet moves near to the coil, then what happens? The magnetic flux changes and electromotive force, that is EMF, gets induced in the coil. If that coil is short circuited, then current will flow through this. This is what is a Faraday's law. Now, already we discussed this. What is the position of a magnet and whatever deflection that we saw on a galvanometer. So whenever magnet is raised, no deflection. Magnet moves towards coil, there will be deflection on the galvanometer in any one direction. Whenever magnet is held at a stationary position, that is near to the coil, no deflection in the galvanometer. Then when magnet moves away from the coil, now there will be a deflection, but that deflection will be in opposite direction. Whenever magnet is held stationary at the same position, that is away from the coil, again there will be no deflection in the galvanometer. So therefore, here Faraday says that whenever there is a change in the magnetic flux which is associated with a coil or linked with the coil, an electromotive force, that is EMF, is induced. So whatever EMF which is induced, its magnitude depends upon first change in the magnetic flux and second one will be time in which flux changes. Now let's discuss second important law, that is the Fleming's law. Now here the direction of a EMF which is induced in the coil, it depends upon there is an increase or decrease in the magnetic flux. The left hand and the right hand thumb rule was given by John Ambrose Fleming in the late 19th century. So this is he is a Fleming, he is a scientist, and he gave us left hand and the right hand rule. Now, what is the Fleming's left hand rule? The direction of an induced EMF, it depends upon whether there is increase or decrease in the magnetic flux. So, according to the Faraday's law of electromagnetic induction, whenever a moving conductor is placed inside a magnetic field, let's say if a magnetic field is stationary, a current will be induced in that. And if the conductor is forcefully moved inside the magnetic field, then there will be a force experienced. So there will be a relationship between direction of an applied force, magnetic field and the current. Now let's discuss first Fleming's left hand rule. Now here you will observe that in the name itself, this is a short form for a Fleming's left hand rule, that is FLHR, and it is used for a motor. So purposefully I have made this letter red because you can remember this FLHR, that is Fleming's left hand rule. It is used in the motor. Now in the spelling of a motor there is only one R, and here in a FLHR there is only one R. So we can easily remember this as FLHR, that is Fleming's left hand rule. It is used for a motor. So now here you will observe that. I will show it to you. Now this is what is my left hand. Now arrange your, this is a thumb, this is your first finger and this will be your middle finger. So arrange it in such a way that there will be a 90 degree, that is angle between these three will be 90 degree. So in that case what you will observe, this is your F, this is B and this will be I. What it indicate? F is nothing but force which is there on the conductor. B is nothing but it is the direction of a magnetic field, and I is nothing but direction of current. So this is what is a Fleming's left hand rule. Now it is mainly used in the application, that is in the application of a motor. The main purpose of this rule is to find out the direction of a motion in an electric motor. So this is what is Fleming's left hand rule. Next is Fleming's right hand rule. It is mainly used or it is applicable for electric generators. So here again I will use my right hand now. Here you will observe that suppose if I stretch my thumb, this is thumb, this is first finger, this will be middle finger. So if I arrange it in such a way that now here there will be angle. So what you will find, if the forefinger represents the direction of a line of a force, this is a forefinger, then if the thumb points in the direction of the motion, this is a forefinger here, so it indicates what? This will be your direction of a field, this will be your direction of a current, and this is nothing but your force. So therefore, what is the statement? If the forefinger represents the direction of a line of a force, the thumb points in the direction of a motion or applied force, and the second finger points in the direction of a induced current. Now, let's discuss what is a generating and motoring action. Now, what is motor? Motor is one which has an input energy, that is electrical energy, and which has the output energy, that is a mechanical energy. So what do you mean by a motor? When we give electrical energy as an input and output is a mechanical energy, then it is called as motor. Whereas the exactly opposite is there in case of generator. To the input mechanical energy is there, and to the output we produce their electrical energy. So this is what is the difference between motor and generator. Now let's discuss what is the difference between motor and generator. Now the basic function of the motor is it converts your electrical energy into mechanical one, whereas in case of generator it converts mechanical energy into electrical one. Then here motor uses electricity but generator will produce electricity. Now, what is a driven element? The shaft of the motor is driven by the magnetic force which will be developed between armature and the field in case of motor. Whereas in case of a generator, the shaft is attached to the rotor and is driven by a mechanical force, by a hand, let's say. Here, current. In a motor, the current is to be supplied to the armature winding. Whereas in case of a generator, the current is to be produced in the armature winding. Then which rule here we have to follow? I already told you. Whenever there is a motor, in the spelling of a motor, there is only one R. So you have to use FLHR. That is Fleming's left hand rule. And whenever there is a generator, now here you will observe that in a generator spelling there are two R's, so you have to use FRHR, that is Fleming's right hand rule. So you can easily remember in this way. Now what are the examples of the motor? There are number of examples. An electric car or the bike is an example of an electric motor in which we can use the motor. And whatever energy in the form of electricity is generated at the power station, this is an example of a generator. So this is what is difference between generating action and the motoring action and basic laws associated with generator and the motor. That is Faraday's law of electromagnetic induction and Fleming's left hand and right hand rule. Thank you.